let's get into a very quick round of introduction. I'll start first, and then I will hand it off to Amitabh, and then we can just go by, the participant list that I see in the in WebEx here. So my name is Guru Bala. What I do is I lead what's called as the a specialist solutions architect team at AWS. So me and my team, we work with customers and help them adopt some of the specialized and advanced services of AWS: analytics, machine learning, containers, autonomous computing, and all those new technologies that have come up. And I'm based out of Bangalore. So that's a brief introduction about myself. Amitabh, over to you.
I head the startup business development ecosystem for AWS. I come from an entrepreneurial background myself. Last 5-6 years, I've spent building a digital health platform on managing chronic conditions. And previous that, I was running an ed tech company that worked between US and India. Thanks, Guru.
Yeah, thank you, Amitabh. We can start with Abdur. You want to go next?
Can you guys hear?
Yeah.
So how much time do I have, guys?
10 seconds for the introduction, Abdur, and then we'll do the fireside chat followed by the roundtable discussion. Yeah.
Okay, sounds good. So this is Abdur. I'm the CEO of Xcode Life Sciences. We are a genomics company, consumer genomics company, and we are heavily into data and health tech. So that's brief.
Thank you, Abdur. Abhinav?
Hi, everyone. I'm Abhinav. I head the technology and product for PharmEasy. We are essentially in pharma e-commerce and also have presence in the B2B side for pharma business.
Thank you, Abhinav. Ajay?
Yeah, hi, myself Ajay. I'm heading technology team here in HealthCart. About HealthCart, basically, it's basically into selling health supplement and sport nutrition. We are a brand company. Along with that, we have an omni-channel platform. So yeah, that's a brief introduction about me and HealthCart.
Thank you, Ajay. Ajit?
Hi, so name is Ajit, one of the founding members and head of product and technology in Infine. So we are a healthcare startup focused on primary and secondary healthcare delivery.
Thank you, Ajit. Next is Amit.
Hey guys, good afternoon. This is Amit Gupta. I'm CTO at Healthians. Healthians is primarily into diagnostic space. We are India's largest at-home blood collection service. We are currently present into 40 plus cities. We operate into B2C as well as B2B space. We have recently also forayed into telemedicine during COVID time. And it is really a pleasure to be talking to you all. Thank you.
Thank you, Amit. Ankit?
Hey guys, this is Ankit. I head engineering for our core businesses here at CureFit. CureFit is a 4-year-old startup in the preventive healthcare space. We primarily work in the fitness, food, mindfulness, and primary medical care space. And I apologize for the 10-year-old or 12-year-old photograph in the slide there. Yeah, that's me.
Thanks, Ankit. Next is Bala.
Hi, good afternoon. I'm Dr. Bala. Till last week, I was a senior principal scientist at CSIR. So just this week, I've joined my wife's startup, Advert Diagnostics. We specialize in developing point-of-the-care solutions for skin and soft tissue infections. Specifically, we are looking at wound care and cosmetics market, leveraging multispectral autofluorescence imaging combined with AI for various clinical applications. Thank you.
Thank you, Bala. Sekar?
Hey, hi, this is Inba here. Hello, am I audible?
Yeah, you're audible, Inba.
Perfect. Hi, guys. I'm Inba here. I'm the CTO and co-founder at DocSap, Medibuddy. And we are a digital healthcare platform providing online and offline consultations with doctors and laboratories and medicines and lab tests as well. So we're about a 5-year-old startup in the healthcare space.
Thank you, Enba. Hey, we have also got Gaurav from AWS. Gaurav, you want to very quickly introduce yourself?
Hey guys, my name is Gaurav. I lead the startup team for the West and North of India. Glad to have you guys here. A great show of all talented people.
Thank you, Gaurav. Dr. Geeta, you want to introduce yourself?
Hi, I'm Geeta, CEO and CTO of Miramai Health Analytics, which is a startup where we're using machine learning for breast cancer detection. And we use thermal imaging, and essentially medical imaging and AI is our current focus. Thank you.
Thank you. Nidhi Jain?
Yeah, hi everyone. This is Nidhi. I'm running a company, Care Expert, which is like a 4 years startup now. It is funded by Reliance Jio, and we are focusing on a B2B SaaS model, digitizing the mainly hospital and its chain. And we are based out of Gujarat. So that's about it.
Thank you, Nidhi. Prasad?
Hi everybody, I am CTO at HealthFlix. We are on a mission to digitize Indian healthcare via EMR adoption. We have around 7,000 doctors using our EMR to treat about 1 lakh patients daily.
Thank you, Prasad. We have Rahul from AWS. Rahul, you want to introduce yourself?
Hi guys, I'm Rahul. I'm the CTO and co-founder at Livelight, and it's been 6 years into the Livelight, and we are trying to solve the healthcare as a whole problem in the country.
Thank you, Rahul Narang. We have Rahul Jain also from AWS. Do you want to introduce yourself, Rahul?
Hey guys, my name is Rahul Jain. I basically lead the startup marketing efforts at AWS. Thanks for joining all.
Thank you, Rahul. Hey, next is Ranga. Ranga Shetty, do you want to introduce yourself?
Hi, Ranga Shetty. I am mentoring a few startups in the healthcare arena, one of which is Attune Technologies, which has products in the diagnostics and patient engagement areas. Also working with a startup in the health insurance area. So health tech data is of key interest to all the startups.
Thank you, Ranga. Next is Ravi.
Guru, I think Ravi's having audio issues. Maybe we can get back to him.
Okay, sure. Richik, last one.
Hi guys. Hi, this is Richik. I'm the CTO of Remido. Remido is helping doctors through tag to connect with their patients via telemedicine, as well as we are helping patients to understand about their conditions through our digital care program, as well as we are providing insights to our patients.
Thank you, Ruchik. Thanks everyone for the quick introduction. I'll hand it back to Amitabh for the fireside chat, and we can get going on this. Amitabh, do you want to take over?
Yeah, thanks, Guru. Hey guys, welcome. Great meeting. Such a brain-powered health tech room there. Welcome Abhinav and Ankit. Indian healthcare is a very unique. Indian healthcare is a very unique problem to solve for. Fine, we 1.3 billion people, less healthcare doctors, less staff, less of infrastructure. The only way to expand this is using tech. Fine, and you both are solving preventive as well as curative. Fine, one of you, CureFit, is solving a preventive, and PharmEasy is solving a curative. Could you just? It'll be good if you could share deep insights into how you're leveraging tech to solve these grand challenges. I'll leave it to you, Abhinav. You can go first.
Sure. Thanks, Amitabh. Really good to be in the company of such an esteemed panel. I represent PharmEasy here. PharmEasy is largely known as a B2C pharma e-commerce setup, but we are actually a much more diversified setup. in the OPD space, that is in the curative healthcare OPD space, we have presence on the doctors front. We have presence on the pharma service deliveries, pharma product delivery. On the B2B side of it, we are also a B2B marketplace. So if you look at the curative OPD healthcare space, there are 5 key stakeholders in this ecosystem. Of course, the patient, the doctor, the retailer. In this case, it could be a diagnostic retailer or a pharma retailer, the distributor, and of course the pharma companies. Right? These are the 5 key stakeholders in this ecosystem. And unlike most developed nations, we are kind of in a very interesting space here in India. There are anywhere between, of course, there are 1.3 billion people. That's one part of the problem. Then you have about 10 lakh registered practitioners in the country. There are around 8.5 lakh retailers. There are about 1 lakh distributors, and there are more than 2,000 pharma companies in the country doing business at scale. Contrast this with most developed nation. If I were to take example of the US, for instance, of course, the population is 1/4 of India, 1/3 of India, but just from a retailer distributor perspective also, there are like 3 retailer chains that control almost 80% of the US market. And similarly, there are 3 distributor chains that control 80% of the US market. And the problem that we have in our country is that it's an extremely fragmented space. So you may have demand somewhere in the country, and you may have the supply somewhere else in the country, but because the system is so disconnected, these distributors, these retailers are so disconnected from each other, you're not able to marry the demand with the supply. So fill rates in our country are in the range of 55 to 60%, which means that once you walk into a store with a prescription in your hand, there is only 60% chance that you'll get all your medicines. And this is the country average. So if you take it to the tier 2, tier 3 towns, you can imagine the effect this kind of a average percentage would have in those cases, right? So what we are trying to build is an extremely connected ecosystem. Starting from the pharma company, we are trying to build an integrated supply chain of distribution as well as retailers. While of course Pharmeasy is the face of everything, and we are a B2C setup, we have a very significant B2B presence, and that is completely technology led today. We fill our supplies almost on a daily basis, right? That's how we are assessing the demand in the ecosystem, and we are taking it back all the way to the supply, the general distributors as well as to the manufacturers to kind of have better fill rates. So the fill rates on the platform are in the range of 95%, 95 to 97%. Compared to the industry average of 60%. And that's largely because of the fact that we've been able to connect these 5 stakeholders, from doctors to patients, of course, through Pharmeasy and through our EMR platform. And of course, behind the scenes, it's a deep supply integration that allows us to kind of have better experience for the end users, more affordable access to healthcare.
That's interesting. That's interesting. Yeah. You integrating the entire system, and even forecasting medicines is actually a very big challenge. Right. I hear that. And Ankit, my same question is to you. Fine, in a country where preventive, infrastructure of parks, etc., the knowledge is not available. And preventive is so important to decrease the whole cost of healthcare, because if you are able to manage preventive, then you don't, one will decrease the sick care cost of going to hospitals. Fine, and you're doing some amazing work leveraging technology to scale that. Could you just give insights there?
Yeah, I think you said it rightly, but I think knowledge is not the only problem there, right? So what we are into is basically holistic healthcare, right? So what we say is that if you have any health goal, right, and a health goal could be as simple as or as straightforward as weight loss, or it could be something like managing diabetes, or sleeplessness, or whatever it is. But if you take any health goal, which typically requires you to have very long-term discipline, right, and it requires you to work on multiple aspects of health, right? So what we are saying here is that you have 4 aspects of health. Nutrition is right up there, followed by sleep, and then followed by physical fitness, and then finally access to good diagnostic and medical capabilities, right? people just think that, if let's say, if you take any example, let's say example of weight loss, people just think that, if I eat right, I'll be able to lose my weight, but that's not how it works. You have to work on your sleep, you have to work on your fitness. Similarly, if you are having trouble sleeping at night, right, people just say that maybe it's because of stress, but it could be because of the food that you eat, right? So health is super complex. It requires you to work on these 4 aspects, and also it's very different for everyone, right? Like how it might work for you might be completely different from how it might work for me, right? So, which means it needs to be personalized, right? And any solution in any space, or not even just health, any space, if it needs personalization, and it requires a lot of data, right? So that there can be systems, there can be plans that can be personalized, created for you, right? So that's where I think CureFit comes. So what we say that we have this integrated platform where you can cover all these 4 aspects of health, and now we are very actively working on solving these uh, uh, problems, like the ones that I mentioned, in a much more holistic way. I think till now what we have done is we have kind of employed tech and solved these solutions in an isolated manner, where if you are interested in fitness, you have a very good platform to kind of fulfill that need. If you're interested in good nutrition, we have a platform for that. Now we are actively working on kind of marrying all of these to give holistic healthcare solutions.
Thanks a lot, Ankit. In fact, hand it over to Guru, because one area that we're going to talk a lot about is actually one thing that you suggested is personalization, right? And if you go a few years back, nobody thought that healthcare can be personalized, diet can be personalized, and there are so many people in the panel that we have who are doing a lot of wonderful use cases in just personalizing with so much of data available. Hey, Guru, over to you.
Hey, thanks, Amitabh. Hey, so going back to what Abhinav said, question to you, Abhinav. You spoke about the supply-demand constraints and availability constraints across India, and 60% is what you were expected to get, or at least that's what the data point is showing. So in this across all this, where do you think we have come in terms of digitization of the entire healthcare ecosystem? Where do you think we have made progress, and where do you think we are lagging in progress with respect to digitization of this entire ecosystem?
Sure. See, I mean, I think there is a long way ahead of us. I would think that we've just begun in the last, I would say, in the last 3 to 4 years, 5 years, right? My belief is that, however unfortunate this current pandemic situation is, it is going to help accelerate things. See, it's a highly regulated area, and rightly so. It needs to be a regulated area. It shouldn't really be free for all. Do anything you like. You're at the end of the day, you are dealing with the lives of the people. But what has happened is that these regulations have made it very difficult to bring in the latest technologies that have come about in the last 15, 20 years. See, most of the software tech has come about in the last 15, 20 years, but the curative healthcare space, or even preventive healthcare space, has been around for so many years that these regulations make it very difficult to change anything. The inertia is just crazy, right? And so while as the last frontier, I would say, because most other areas have seen disruption in the country, from general retail to transportation, etc., and now education and so on. Healthcare, unfortunately, has not really seen so much of penetration of technology. Things obviously are changing now, and I believe because of the pandemic, there is this realization in the authorities, that the only way to solve for the size that we are in India, it is to have software penetrate all aspects of healthcare. The Prime Minister also kind of announced the whole National Health Stack initiative on 15th of August, but I think it's still going to take some time. The modalities of it are yet to be figured out, but things certainly have accelerated because of pandemic. The initiatives that are now coming about, the policy changes that are now coming about, perhaps would have taken at least another 2 to maybe 4 years. And in that sense, I feel I'm very optimistic that over the course of the next 4 years, we will see a lot more penetration. Today, in bits and pieces, we are all trying to solve issues. So let's say We are trying to solve problems in the curative space. Ankit talked about how they are trying to solve problems both in preventive and curative space. I think there are these initiatives that are happening now, but a lot of the space is still highly regulated, which hopefully should get better, more relaxed over the course of the next, I would say, 2 to 3 years.
Hey, thank you, Abhinav. Hey, a question to you, Ankit. You mentioned the multiple dimensions about even when we talk about sleeping and how it can get affected because of food, stress, and everything else. So, how are you leveraging technology, and how do you think technology is changing the landscape of preventive healthcare?
Yeah, I think, and this is something that has happened very recently as well, which is we are seeing this huge advent of two things in this domain. The first dimension is the devices, right? We are seeing huge number of devices that are now entered into the market, primarily in the sensory domain. So starting with the camera, right? So if you look at how fitness has changed in the last year, it's huge, right? How we had been working out for the last 20-30 years is probably very different from how it would be in a couple of years, right? This has primarily changed in the last year with a lot of devices, primarily driven by some kind of a camera, have come into the foray, right? So we have now, we have now technologies which, using computer vision, can look at a person's body, can see what exactly are they doing, can even count their reps for them, can detect their form, can even correct their form, right? So a very personal way of doing fitness at the comfort at your home and at the safety of your home, right? So till now, we always used to think of home as a convenient thing, but now it's a safety thing, right? So now the definition or the reason of working out at home has completely changed, right? So that is just one aspect of it, which is just cameras and computer vision. Another one is just other kind of sensors also, right? And this also happened with the recent merger of Teledoc and Livongo also, right? So we are seeing this new kind of new age devices, glucometers, thermometers, SpO2 sensors, all of these kind of coming together to give you a very accurate picture of what your human body or your human mind's current state is, right? So that is one aspect of it, which is the sensors and the hardware play. But the more exciting or the more the bigger chatter that is now coming is the intelligence that has been built on top of it, right? So huge amount of personalization and AI is getting built. We are seeing a lot of apps, a lot of companies coming up with the AI fitness coach, right? So you don't need to, in a few years, you won't need to, talk to a human to solve all of your fitness needs. Similarly, there are companies, including us, working on a AI nutritionist, right? So if you want to come up with your, let's say, meal plans, and based on your current stats, your current allergies, or anything that you're going through, how can we come up with a personalized meal plan, right? In fact, it's going even one level further, where people are now talking about AI doctors and AI medical imagery and stuff like that, right? So I think this second layer of intelligence and personalization that is getting built on top of the first layer, which is the sensors and the data, whether it's getting captured by a device or whether someone is entering them manually. I think that is these are the two fronts I see at least has been changing very fast in the last 1 year or two.
Yeah, thank you, Ankit. Probably, later on in the session, we will definitely come back to this topic more, especially with Dr. Geeta and a couple of others, on how we have been leveraging AI, ML, and everything else. So I will hand this back to Amitabh to kick this off across a larger cohort. And before that, I think I missed intro for two people. One is Ayush Jain from AWS, and another one is Ravi Gupta. So can both of you very quickly introduce yourself, please?
Hi everyone. I'm Ayush Jain. I'm a part of the startup in the venture capital team at AWS. I'm usually behind the scenes, so you must have seen emails from me for planning this and inviting all of you. So great to have all of you. Good news is that we have a full house. So we got 15 confirmations, and we have I think as per the count we have 15 people. So thank you, group, and look forward to an awesome discussion.
Thank you, Ayush. Do we have Ravi as well? Looks like there seems to be some problem with Ravi joining this, or we're not able to hear him. Let's go forward. Amitabh, do you want to take over from here?
Sure, I will. Thanks, Guru. Thanks, Guru. It's wonderful to have this group together, as we said, and healthcare being such a massive technology problem to solve with data standards at one place and devices coming in which are just changing the way how people engage, right? And that's the reason that it's good that all CTOs getting together, they can actually exchange wonderful thoughts. So we would have loved to have this event in person, but we said that we'll just get very similar thinking people together and make this a wonderful event for you to collaborate, share, and even later on, just please engage. One thing we've seen that with post-COVID, when patients could not visit to a doctor, and we talked about telehealth for so long, and we saw huge amount of tailwinds and doctors reaching out to technology vendors and saying, "Hey, give us this, give us this solution to telehealth." In this group, we have Arjit, we have Amit, we have Imbasspec, and there are many people who looked at telehealth. And you guys have been, you guys basically came into this space earlier. What inspired you? How are you using technology? And I know a few of you, like Arjit and all, are using AI for OPD care as well as telehealth. You're fundamentally increasing the infrastructure capability in India, democratizing health to some extent. Ajit, can we go with you and start off as to what are you doing, how are you leveraging tech, etc. in this space?
To me,
yeah.
Okay. So I think Abhinav just talked about the constraint of the whole ecosystem, right? I think it is just to put it simply, it's a huge supply-demand mismatch, right? And that's what we're dealing with. And more so when it comes to doctors and let's say primary care delivery, right? If you look at it, I mean, just not to just rattle off some stats. We have something like 1 to 5,500 odd, one doctor to 5,500 odd patients when it comes to standard specialties. And if you look at some more deeper specialties and super specialties, the numbers are even worse. Right? And we are keep going on adding every year more NCD patients, more than any other country in the world and so on. So the problem is just getting worse and worse. So essentially, when we talk about a primary care delivery, this is essentially what we're trying to solve. First of all, access becomes an issue. How do you get access to good doctors if there are good doctors? And second, whenever an encounter happens, how do you ensure that transaction between the doctor and the patient is actually giving some quality clinical outcomes for the patient, right? And that's what you need. If you really look at it, medicine is a science, but it almost behaves like art. Right? It really depends upon which doctor you went to and what he did, etc. Right? There is no guaranteed outcome that you can get, and it's odd that it is being science. It behaves this way. So essentially, this is the mismatch that we are trying to solve at Untitled specifically. Take a select good doctors, put them on a network which is virtually accessible by patients, and thereby you solve the access problem. So irrespective of which geography you are in, you can actually get access to the best of healthcare available to you. But then to solve the problem of the time, I mean the supply and demand, right? Few good doctors, millions of patients, not going to work. So you got to make that non-linear scaling, and for that we use AI. So I think it was briefly referred in the conversation before that something like a virtual doctor. So what we essentially do is we try and offload as much as possible a typical consultation journey into the machine, that it is able to offload a lot of this ability from the doctor, do it in a more scientific way, driven by clear protocols that too which are learned from the doctors themselves. So it almost becomes like a digital avatar of sorts in the system, which is able to then do everything from investigation, a differential diagnosis, a treatment plan preparation, etc., much in line with what you would have done. So that the doctor can come and just quickly glance through whatever it is concluded and give the patient the care that he needs, right? And this is essentially what we do. And of course, it's not we employ different techniques of computer vision, auditory signals, language, all of that, and mix it into multimodal sort of an inferential system, right? And extend that to medicines and e-diagnostics, so to say. We do that as well, because end to end, we want to offer this as a capability. And these are places where we are using AI.
Thanks, Ajit. I think that's a phenomenal way to scale up health infrastructure in this country and even democratize it by just creating an avatar of a doctor by using the rules, etc., that how he looks at. I think it's phenomenal. Amit, though there's a lot of work that you're doing in the diagnostic space, becoming the largest diagnostic service, but there's also the telemedicine interest that you have. How have you looked at this space, and what are you doing differently? How are you serving the population in India using tech in this space?
Sure. So we are primarily into diagnostic space. So when COVID started around March, then we all experienced that people stopped using any services. People stopped going to doctors stopped meeting to patients because of this COVID panic, and all things started getting delayed. So a lot of our patients or customers, they were in the need to meet doctors, and there was a kind of medium not available, in the sense that how do we meet doctors? So they were like, people were talking to their doctors over WhatsApp and all those things. So we took this as an opportunity to build a telemedicine platform. So we launched this telemedicine platform during this COVID timing. And in India, where medical professionals to general population ratio is so less, in the sense like we have very lesser medical professionals, I think this is a way to go, because in tier 2, tier 3 cities, we are seeing where specialized professionals in medical fields are not available. This is the longer term to go. When we launched this platform, all of a sudden, our customers, our patients, they started using this service, and they were easily able to talk to their doctors. Doctors were easily able to prescribe what needs to be done, and we were able to provide service. So this is how we completed this ecosystem during this COVID timing. We also came across one more challenge, that people who are in their 20s, in their 30s, they don't need these kind of medical service so often. People who need these services, they are primarily into their 50s, 60s, or 70s, right? And they don't know how to operate technologies. For example, if you want to provide a video consultation, and so my doctor is aware that population below 40 or 40 until 50, they are aware, but my father doesn't know how to operate a smartphone. My grandfather doesn't know how to operate a smartphone. So there we see the people who want to avail the service, they don't know how to use technology. So we were again like a scale one, like what do we do? People who need this service as a telemedicine kind of thing, they can't use this. So we launched another service. We have a platform of phlebotomists on the field who go to people's home to draw the blood. We use that army of our phlebotomists, and people who feel challenged to use technology for telemedicine, we help them. Our phlebotomists go to home, we set up technology, we take a lot of parameters where doctors need, for example, what is the blood pressure, what is the ECG, what is the glucose, what is the temperature. So if all those equipments are not available, so we are using sensors and a lot of portable instruments. So we take those information, we put in our system, and doctor on the other end is able to get all that vital information, is able to prescribe what needs to be done. So I think this is another way where we had not thought before that we will face this kind of challenge, but I think this is the real thing which happens on the field, and this is how we are solving this thing. I think telemedicine in India is a long way to go.
Yeah, that's a phenomenal thing that you've done, and you will see as civilizations become older, there is going to be a huge need for managing old people by just monitoring them at home. So what you're creating is actually going to be extremely beneficial as you go forward. Fine. So I think Ambassador, you are also working in this area of telehealth. I'd love to have your thoughts. How are you using deep tech in connecting the patient and the doctor? What are the challenges that you see, and how you solve for latency, etc., in that area?
Yeah, thanks, Amitabh. I think we've been in the telemedicine space for the last 5+ years, right? Primarily doing a lot of teleconsultations. One is, of course, the technology does come in handy. It also gives us a unique perspective, right? Erstwhile, when consultations happen, they're all happening as in small pockets, right? Like there's a doctor seeing 10 patients, 20 patients a day. There's no exchange of information. There's no aggregate of quality measures and so on. So one of the added benefits, apart from the access or the COVID-related challenges, which is solved by telemedicine, because of it being digital and data and aggregated, there's a lot of insights we could derive out of the consultations that's happening, right? Like what the quality of doctor, what's a doctor's behavior. The same doctor behaves differently in the morning versus an evening. So a lot of these insights are very, very unique, right? Therefore, and this can also go back to the medical community as well, right? Like in terms of insights that can be used to treat patients better, to get better health outcomes, right? One of the challenges in even physical consultations is that whenever a doctor meets a patient, doctor says, come back after 3 days if it doesn't work, right? And primary healthcare is largely about not always testing is done to confirm the diagnosis, right? Sometimes it's you treat, there's a trial and error of sorts that goes on there. Whereas the power of technology or digital platforms, apps, notifications and whatnot helps us to close the final loop as well, right? Did the patient adhere to the medicines given? Did they really get better at the end of it? Or if not, like what's the the level 2 kind of treatment that needs to be given? So these are became added advantages which was unavailable to the patient, right? Patient either feels better and doesn't go back to the doctor, or if they don't feel better, they don't go to that doctor and change the doctor to another person, right? So then there's no continuum of care or no complete health view that gets missed out, which with with technology platforms, it's an added advantage. And there's an unseen scale of data as well, right? In healthcare space, right? Of course, in retail and e-com and other places, it's well known. But I think for health, it's very unique, right? The kind of scale of information that really helps, both to give feedback to the doctors, and doctors are also very apprehensive, right? If it's data-driven feedback on how what is a good consultation, right? Like somebody likes some doctor, somebody doesn't like some other doctor. Like what's the science behind it, or as Ajit called it, there's an art behind it, but can we still do a model around it to figure out, hey, why this doctor is being liked versus another doctor is being liked when the medicines are the same, right? Like, or when the diagnosis is the same. So some of these has been very, very interesting learnings in the past few years. And another key aspect is, of course, it's a problem to solve. It's something the doctors value. And of course, COVID accelerates some of these adoptions as well. But fundamentally, because of this aggregation of information and digitizing of information, I think in health, security is very, very key, right? Like the kind of information that there is always the saying, right? Everybody says all the truth to a doctor and the lawyer, right? And if we are a platform where that is being used, it's a lot of sensitive information do get shared. So data security becomes a very key important without losing agility, right? So that's where again tech platforms does help, right? As a startup, you cannot invest a lot in all of the areas, and at the same time you cannot slow down in terms of what we push out in terms of products and features and user experience. And that's another key area where I think it's getting improved, right? Where to have secure cloud-based platforms, but at the same time have the agility to deploy and scale things faster.
That's great, and I absolutely love the analogy of science and art. And I just think that algorithms, which could be art, and once you actually have scalable data, algorithms govern the decision making. You're actually merging science and art together and creating infrastructure in India that can serve the population that India has. Thanks, guys. Guru, I'll hand it over to you to talk to and discuss a few questions with the others.
Hey, thanks, Amitabh. Yeah, so moving on, probably I'll start with Rahul Narang, and then I would really love to get views from Abdur, Rajai, Ranga, Ravi, and others. So the question is, there are obviously all kinds of data in healthcare, right? We talk about genome data, which Abdur is working on, which is going to reflect specific health characteristics of an individual. Then there are general patient healthcare records, and then we've got data around clinical trials. So how are you bringing all of this data, and how are you leveraging cloud to do a lot of this analytics and build models around this? Do you want to share your perspectives, Rahul, first?
Sure. So basically, when we started, our objective was to democratize the healthcare, and our idea was a little different because, like as mentioned by Sankita earlier, that there are very less number of doctors compared to the other countries. So it's actually not possible to connect each and every patient to a doctor directly. So our idea was a little different. Our idea was, okay, so let's focus on generating a content out of what doctors are saying. So let's say a patient comes on the platform and he asks something to the doctor, and the doctor replies. So there could be two ways. One is it could be a private conversation, one-on-one, or other way it could be a public conversation without, like, anonymous public conversation, right? Because ultimately, you can say the problems are limited, right? Practically, like, you can say the solution could be different, but in a way problems are limited. For example, if someone is having a stomachache for 5 days, like, there is someone else who can have with a similar problem. So idea for us was to generate a lots and lots of such queries from the patient perspective and the doctor's perspective. So in the end, what we built was we created an ecosystem where we have millions and millions of user-generated content, basically the health queries of the patients. Okay, and these health queries are answered by none other than the doctors. So on the other side, basically you can say we have a verified solutions, right? So it is like a free Q&A with the doctors, right? The way the CTOs we are interacting, that's way a patient and doctor can interact, and everybody outside that can benefit from that. So we did that part, and we also created a platform where doctors can interact with more and more number of patients. So we gave them a tools to basically publish health content, come up with their idea of how one can stay healthy and all. So what led to all this was a huge content generation from the doctor as well as the patient perspective. So once we did this, what we have realized is there are lots and lots of people coming in to you can say coming in for their health queries, and we tried to solve that problem. And so which actually created a loss of data for us. And now the problem remains like two things. One is we can have more number of people to moderate this UGC, or we can build the machine, or we can say build the models to take care of all this content, like you can say the Facebook and all these companies do. So what we created was we created this ML models to take care of our UGC, and ultimately what we are left with is a good content which can be served to millions of users. And now started coming the millions of users. Now suddenly these millions of users have started asking these questions or browsing these questions. And now as a library, what we have is what we have categorized the entire healthcare information into more than, you can say, 2000 a health keyword, you can say. For example, a diabetes is a keyword for us, a kidney problem, a stone is a keyword for us. So what we started doing is we started tagging these people to these problems. Okay. So whoever is coming on the platform, now we know what's the problem they are facing, what is their, you can say, their family background, or what kind of problems do they face. So we started generating this lots and lots of data around it, around the healthcare. So suddenly we realized that there's a lot of data. What should we do with it? So then initially, like as a technology company, we thought of, like, you can say, how do we model the data? What do we do with this data? Then we realized this. What we can do is we can create some sort of a health profile of a patient. Okay. For example, initially we call it, यार जैसे किसी की कुंडली होती है वैसे ही किसी की health कुंडली, you can say, कि ठीक है, मतलब this guy is suffering from this problem, or you can say parents are this age, because people generally tend to give this information while talking to a doctor, right? Even in their anonymous chats, right? So now you have this data. Now what you can do with this data is you can probably create a sort of a health profile out of it, and then depending upon what they want to see and how and when do they want to see actually this information. For example, someone might be suffering from a problem which he or she doesn't want to discuss personally with the others, right? So that's how we created this sort of a health profile where they can come and they can get a personalized experience of what they are looking for, what kind of information they are looking for free. And in case they need any sort of a doctor then and there, they can contact the doctor from there and simply pay the fees and contact the doctors. And with time, what we have done is we to monetize this data, we have recently launched our e-commerce portal as well to basically monetize this data. That's it. So for Livelet, I would say data is everything. And to solve this problem, as a CTO, I can say a really handy tool was Redshift. Thanks to AWS for that wonderful tool, because without investing too much into technology, from you can say development perspective or from the operational perspective, we were able to scale things pretty fast, and we were able to build the models around this patient profile very fast and able to solve our problem. Yeah.
Thank you, Rahul. That was really helpful. Abdur or Ajay, do you want to share your perspectives of what are you seeing in terms of data processing? Have you, how have you been able to handle large data sets when it comes to healthcare? Can you talk about that? Ajay, you want to go next?
Yeah, sure, Bala. So, if you see HealthCart is basically into selling health supplement and sport nutrition. We are primarily a brand company, right? We have various brands under our umbrella. MuscleBase, if you know, it's our biggest brand that's into a sport nutrition category. So if you see our TG is basically gym goers, bodybuilders, athletes, and all, right? And the product that we have under this brands, they are basically dietary supplement. And what dietary supplement they basically do, they help user to achieve their health and fitness goal, right, by fulfilling the right kind of macro and micronutrition in your daily food, right? And these supplements basically, they don't work in isolation. As Ankit has rightly said, it's a complex, it's a complex thing, healthcare and fitness, lots of things goes hand in hand, and then only it's work in a holistic view. Same goes with the supplements also, right? It has to be infused with right kind of activity, right kind of food, right right kind of sleep pattern, stress, and everything. And being a brand company and a supplement company, somehow we had to educate to our users that this just taking the supplement does not work for you. It has to be work in a holistic view. And that's where the power of AI, ML, and big data came into a picture. We wanted to create a platform, a digital assistance platform, which is AI driven, having a lots of data behind the scene, and can suggest the user right kind of supplements along with the right kind of a food and activity, using which he can achieve the goal, right? And to basically achieve that, it was very important that first we had to understand the user, where user is starting from, right? Which kind of user is he? What is his profile? How he looks like? What is his goal he want to achieve? What is his BMI, height, weight, body mass, skeleton muscle mass, sleep patterns, and everything, right? So, so we integrated with lots of IoT devices and sensors to capture this information in our platform. The next challenging thing was the Indian food is a very complex itself ecosystem, right? Different people have a different kind of a food preference, and normal vanilla or a canned diet chart does not work for user. Basically everybody has a different food choice. It might be healthy or unhealthy, it depends, but normally the analogy is that the things which taste good, it's not usually healthy, right? So basically we had to combine these two aspects into our system and come up with a diet chart which can actually satisfy the taste bud, at the same time can also fulfill his health and a fitness goal by providing a right kind of diet chart and a health supplement. So we took lots of food preferences from user, that which kind of food they like, and one of the biggest challenge was to come up with a very large set of food database which has lots of dimension in terms of a micro and macro both. So when I talk about macro, it's basically protein content, carbohydrates, fat, fiber. When I talk about micro, it's a long list. It's like omega, triglyceride, vitamin A, vitamin B, vitamin Z, whatever, right? Zinc and all. We combine this complete data set and pass it to our AI model into which plotted this into multi-dimensional way, and the output was, it's basically a personalized diet chart and supplements which can actually satisfy your taste bud, at the same time can take care of your health and fitness goal. And it is personalized up to this extent that even if you got off the track on a particular day, for example, you just started your day and you just ate in a jalebi in the breakfast, so it will basically adjust the rest of the day. Lunch and dinner, the food will be adjusted in such a way that you can still meet your macro and micro nutrients requirement for the rest of the day. And to build this platform, obviously, as I said, we integrated with IoT devices. We are hosted on AWS. For analytics workload, we use Kinesis, we use real-time streaming, we use Redshift, we use machine learning algorithm. So this is how basically we crafted and came up, solve this problem. Yeah.
Thank you, Vijay. That was really helpful. Ravi or Abdur, do you want to talk about how are you dealing with the data problem in your respective domains? Because you deal with a very, very complex set of genomic data, and that comes with with its own set of complexities. Do you want to talk about that? What challenges do you have now? Have you explored cloud, or how have you been dealing with that volume of data?
Hear me now? Hello?
Yeah, we can hear you now.
Okay,
Yeah.
excellent. So, data is now being referred to as the new oil or gold or some other precious thing, right? And that's mostly because different types of data have different values assigned to them. And some types of data are far more valuable than others. And, your DNA data is arguably the most personal data about you. A key differentiator for DNA data is that it's mostly immutable, at least up until now, it's immutable. And what I mean by that is things like your shopping behavior, your content consumption behavior, all of these things will change over your lifetime. And even your health data, for example, your sugar levels, your cholesterol levels, to a large extent depends on your dietary behavior and lifestyle. Except for the DNA data, which is unchangeable, and which is what makes it special, and which is also what makes it, brings in the challenging aspects of it. But if you look at the power of genomic data, I mean, a lot of the speakers today are focusing on the aspect of personalization. Really, if I were to say what's the underlying theme of today's conference or today's webinar, is that how is technology enabling personalization, right? AI driving personalization, and essentially, we come from a world of averaging. Most of us, by definition, belong in the belly of the bell curve. And a lot of the companies today are discussing how we move away from this paradigm and treating an individual as an individual. And up until now, we didn't have enough means to do it, but now we have the means to do it. We have the technology to do it. We have the artificial intelligence to do it, and we are layering, multiple layers of personalization. Age is a layer of personalization. Your blood sugar data is a layer of personalization. Your choice of a smartphone is a layer of personalization. Genetics is, I would like to say, genetics is a very intimate layer of personalization and an immutable layer of personalization, as personalized as it gets. And we see lots of examples of this, right? I mean, not everybody who eats high carbs becomes fat. Not all lean people are healthy. Not all overweight people are sick. Not all smokers get lung cancer, and vice versa. So I can go on and on as to why the whole paradigm of averaging doesn't work, right? We have tools, we have empirical tools, we have observational tools to deal with this lack of personalization now through AI and constant monitoring and data and so on. But one key molecular tool that helps you truly personalize things is genetics, right? It's a hard data, it is unchanging data. You mentioned about the size of the data. I mean, each human has about 3 gigabases in their DNA. And by the time all said and done, if you were to take a genetic test, you will end up with about 100 gigabases of on a pen drive or a cloud. So that's in our company at Xcode Life Sciences, we use AWS for processing our algorithms. Although the file size is about 100 gigabases for each human, science still doesn't know the entire meaning of 100 gigabases. We only understand maybe about 10 to 20 MB. So thankfully, we don't have to yet deal with that entire 100 gigabases of data. We're only dealing with very small sizes. But storage we need to take care of. But in terms of data crunching and other aspects, we're still dealing with smaller, at least at the application level, we're dealing with smaller sizes. But at the research level, we're dealing with very, very large file sizes. In terms of its impact on health and wellness and personalized medicine, you will see in the coming years and decades, you will see genetics penetrate almost every aspect of human life, right from your diet to everything else.
Thank you, Abdul. That's really helpful. Anyone else wants to say anything else about this? Ravi or Ranga, do you have a point of view on this?
Yeah. Hi, this is Ravi here. Can you hear me?
We can hear you now, Ravi. Yes.
Sorry, I'm having some trouble. I think so our firewall is not allowing the Cisco WebEx to work. So anyway, I'll just give a brief overview of how MedGenome works basically. So MedGenome is basically driven by genomics, and we have been using the latest technology, which is called next generation sequencing methods, which can sequence your genomes in now few days, and also we do a shorter version of whole genome. We call it exomes or targeted sequencing, which has been mostly widely used right now. But whole genomes is also are getting accepted in coming future. So one of the biggest challenge that we face, let's say there are many challenges, So one of the challenge with while we want to use AWS, let's say, is moving the data. Let's say you do a sequencing here and generates lots of data. One single run can generate around 600 GB to 700 GB data. Now, if you want to move the data to AWS, let's say, and do the analysis, it is a bigger, big bottleneck for us. And other part of the challenge is also like many of the customer would like to see the output file. So what we end up doing is like we have to download the file and and then share it with the customers. So so we see a bigger bottleneck around that uploading, downloading. So it takes more time to upload and download than actually doing the analysis on the cloud or let's say some hardware-based system that we have. So that's one part of challenge. Another most interesting, actually, it's still open question. Is when we want to analyze a sample. Let's say you got a whole genome or exome data, and you are looking for what could be a causal variant, a causal reason for for the patient. Many of the patients that we receive are actually rare disorders where very less. I mean, there's not much known about the disease, and not and even not known much which genes would be causing that. So it's like you're searching a needle in a haystack kind of problem. It's a typical you can say a bigger problem to solve, and the reason for this is because we still are understanding how different gene works in our body. So we have been using some machine learning based method. We have trained a model. We have built a model that is based on the patient that we have seen so far, and and it helps in identifying some of the causal variant very quickly. Otherwise, it would take sometimes a case can take a week to solve. So scaling up is, if you want to scale up the number of patients that you want to analyze, this is one of the challenges that we face while we work in this area. Other thing that MedGenome does is like basically we largely focus on a lot of solution and the product design as well. For example, we recently have published a paper where we have shown that how we can identify a patient which can be who can have a cardiac arrest. So we can predict from the genomics data early, and then they can consult the doctor, and then they can start taking some medication. So one of the pioneer work that we are doing is in the Indian context is like since most of the publication, most of the studies that are done are mostly Caucasian based and so most of the knowledge that our genetic catalog that we have in all over the world is largely Caucasian. So we are trying to bridge that gap with our data that we have built in MedGenome, and trying to give a better solution or more informative solution to the a patient from India, especially from India or South Asian this part of the world basically. So that's how MedGenome is basically helping patients and we have been working on launching very new many new products, especially also we are working on a lot of direct to consumer tests under the brand name of Apna Genome, where we are trying to give many of the risk scores and which are scientifically sound and based on the Indian patient that we have seen, and also give them some other information on their pharmacogenomic status and other traits that would be interesting to know about a patient, even healthy individuals. So I mean, as it's, most of the work is around our genomics, so that's our a core part of the business.
Thank you, Ravi. That was really helpful. Ranga, do you want to quickly talk about? Saw your note that you talked about seamless movement of data, and obviously if data has to move like currency, there has to be a valid transaction and a reason for the transaction. So it'll be good to understand how are you thinking about healthcare data, and what are the reasons you think it should become more accessible?
Sure. Sure. Yeah, no. So I like to think about this from a patient experience point of view. The kind of problems that we've chosen to focus on is to really look at the patient experience in the healthcare ecosystem. And I like to compare the healthcare industry with the financial industry to really see how things have evolved in the last few years, decades. If you think back less than a decade ago, the number of times you would have walked into the branch of a bank to get any transactions done, right? To deposit a check, to make payments, so on and so forth, and compare that to today. I don't remember walking into a bank branch for years now to get anything done. And I can still get things done a lot more efficiently, a lot more quickly, and so on. Now you compare that with visits to a doctor's clinic or a hospital 10 years ago, 20 years ago, 30 years ago, and you compare that with today, nothing's essentially changed. You still see, crowded waiting areas, whether it's a doctor's clinic or a hospital. You still see patients and their families carrying plastic pouches with tons of paperwork filled in to their doctors when they make visits. So the patient experience really hasn't changed in decades in the healthcare industry. When you compare that with other domains, you can see why there is a crying need to bring about change here. In fact, while all this has been happening, it's not like the medical industry has stayed stagnant. You look at medical technology, there's amazing technology. I'm sure all of you have heard of things like stem cell therapy and radiation oncology, keyhole surgeries. A couple of our co-founders here have talked about genomics and so on. There's amazing advances in medical technology. You can even think of it as space age technology, but the delivery mechanisms in the healthcare industry is still Stone Age. And so the problems that we are looking at is really how do you impact patient experience? And how do you do this at scale? I think a couple of our colleagues today talked about being able to do things at scale for a country like India. So how do you radically improve patient experience at scale is the kind of problems that I'm interested in working on. A couple of startups I'm working with are focused on that. One of the startups that I'm working with a couple of years ago started looking at this in the health insurance space. So we've kind of built a platform where we can actually enable movement of data between hospitals and insurance companies. To streamline that process, and that's taken off really well. In the last couple of years, we've got good traction. We've got a couple of hundred hospitals now working with insurance companies, moving data much more seamlessly than they ever did, which gives huge benefits both to the hospitals and to the patients. The hospitals, are able to discharge patients more quickly. For example, patients, what typically takes at least 4 to 6 hours after a doctor has released a patient, for a patient to actually be able to walk out of the hospital can now happen much sooner. Approvals can happen sooner. You get first-time approvals as against going through back and forth queries with the insurance company. So there's a lot of advantages to being able to move data seamlessly, and we've shown it with an example just in the health insurance space between hospitals and insurance companies. We're now looking at similar problems in other parts of the healthcare ecosystem, like between diagnostic labs and providers of healthcare services and so on. So that's so that's why I mentioned that in my brief to you, that movement of data, liberating data from the silos that exists in today, will really unleash a lot of disruptive innovation that can actually radically transform patient experience and be able to do that at huge scale.
Thanks, Ranga. Do you want me to?
Yeah, please go ahead, Amitabh.
Yeah. As I said, started off, and I said we've got a classic panel of CTOs. So at one end, one startup creates the data, the other moves the data. So if all of you get together, you create the data and you move the data, you'll solve the end-to-end problem, which actually is something called, and India is trying to solve it, which is the India Health Stack. Fine. And then somebody of you can go further ahead and even through imaging create the data, what Geeta is trying to do. So my next, kind of larger this thing is, we've touched base briefly on it, but one of the most important areas is we've all gone to a doctor's clinic. We know it's not digitized, but we've got entrepreneurs here, Prasad, we've got who's actually looking at, Prasad's doing it as well as Richik is doing it. And we earlier talked with, we earlier talked with a lot of the telehealth guys. They're also creating data, but we've seen HealthPlex doing it at the doctor's clinic. Fine. So what are the challenges given a doctor's consult is very limited? How do you do it at that scale that you are doing it?
Hi, so when we started HealthPlex way back in 2016, if you see, there were about 400 doctors using any kind of an EMR tool, digital tool. So that is about 0.4% of the whole India, where there are about 3 to 4 lakh active doctors. So digital is, whereas compared to US, where it's 90%, where it's mandatory, here the doctor has a choice. So if the software is helping the doctor, only then he is going to use it. If the software is slowing him down, obviously is not going to get coordinated. So the first thing we had to solve is making him faster, productive if he is using the software. So we had to blast away the myth that software is going to slow you down. So instead, we have to showcase that the software is going to make you productive. So that was the challenge that we took up, and we did that at scale with using personalization. Today, the doctor, the EMR that we have gets personalized to the doctor within few days, within few number of patients that he treats, and immediately he becomes productive within few days. So immediately he realizes the value and he stays on. So today we are personalization with the doctor, and we are going to the personalization levels of the patient. So it understands, EMR understands which patient he is about to treat, and then the whole personalization drop down his everything on the visit pad gets personalized for the patient. So doctor can produce a prescription under 30 seconds. So that transforms his the time he spends with the patient. He can spend more time with the patient. He can better outcomes for the patient. So the personalization and making the doctor productive is something that we focused on today. Because of that, we have around 7,000 doctors across India treating about 1 lakh patients daily. So our software is used to treat about 1 lakh patients daily. So that's a huge amounts of data that is helps us do the personalization at scale.
Thanks,
so
Prasad.
we do the same thing for other specializations and helps in personalization.
Thanks, Prasad. I don't know how many of them have seen their prescription, but just getting a prescription done in 30 seconds is a challenge, and I that's hats off to you that technically you've been solving that. And similarly, I think if you look at it as this question, my question is again, Ankit, Abhinav, and Richard, even to you. I'll just extend that a little. So one is digitization is happening, like what Prasad is doing, and the other is what we've seen is that people have mobile phones, and if you look at your iPhone, it's got a bunch of sensors. You are all wearing watches, you're all wearing Fitbits. So at one end we've got Prasad, who's actually digitizing the clinic, and the other place that we've got actually sensors, and then we've got a mobile phone. Now you put all the three things together, there is an evolution of another thing that's happening in the industry where insurers are paying money for that, and that's called patient engagement. I would think that patient engagement is very necessary to be nudging, and I think Ankit must be doing that for nudging good behavior. You must be nudging in terms of compliance to just the clinical protocol that has been specified. So can we have Richard talk a little bit about how are you solving the digital health problem of in creating data or in patient engagement, and then we can follow that with Ankit and Abhinav.
Sure. So thank you, guys. So basically, what we are doing is we started with our story that we do not want doctors to change behavior. So we pitched that if you do not want to write a digital EMR, then so be it. You just upload a record. So that's all we need. However, slowly we added EMR also. We have a fully working telemedicine platform. We have more than 7,000 doctors spanning using our system. Another aspect that we touched upon and which is very critical right now is the digital care for the patient. And because of as you rightly mentioned, Amitabh, there is a compliance reason for that. We want patients to get well sooner, healthcare outcomes, and there is basically a growing mistrust between doctor and patient. That sometimes patients think that okay, doctor तो पैसा बना रहा है, वो कुछ मतलब हमारा भला चाहता है कि नहीं पता. So we want to bridge that gap also. We want to increase the trust between patient and doctor. So what we are doing is we are creating these customized journeys for the patient, and these journeys are activated by a doctor. And we are targeting chronic condition patients, and we started with women's care. And these journeys are very useful in terms of getting good authenticated information to the patient at the right time, very personalized information also, because it's coming via the doctor. There is a mutual trust between the doctor and the patient that patient thinks that this is doctor is taking special care of them. Via these journeys also we are creating actionable items to the patient. Things like basically if you have to come up for a follow-up visit, you can do that. You will get a timely reminder. As well as if there is an ultrasound due, if there are things that are due that you have to take for the betterment of your health to improve your health outcome, then your software, your tool will provide you the timely reminder for that. On top of that, we are, basically we started with, women's care. We are going into other specialties, creating this customized journey. This has seen, tremendous response. So, now as the COVID is easing up, a platform which is kind of holistic from the perspective of doctor as well as the patient I think is the way to go for, so only the telemedicine, just EMR, I think maybe it is less visionary.
Thanks.
Yeah.
So how does patient engagement, Ankit, help you find? Because as you said that you give there are goals that the goals that your customers have, and I won't call them patients technically because they're not sick, fine. And these are given by the nutritionists, by the coaches, by behavioral coaches. How are you using patient engagement technically, and are you able to leverage personalization in engagement, mobile sensors, etc.? It'll be great for you to give some thoughts there.
Yeah, so I think there are primarily two buckets of kind of benefits that we get out of this thing. I think one is on the doctor or the nutritionist or the therapist or the trainer side, depending on what product you are using, right? So on the supply side, there is a very clear benefit. Like one thing that Rishik said, that they don't change how doctors want to behave. If they want to write it on paper, they will write it on paper. But there we have changed the direction completely. And what we say is that how can we make their job super easy, right, and still get all the data on the platform, right? So like in case of doctors, what we do is, because we have users using a lot of our products, we have some what we call a unified health profile, right? So data from all of these aspects, whether that person is undergoing a weight loss treatment or if they are doing a particular workout at a cult center or something, all of this comes to a unified profile which goes to the the expert in a unified form. And whenever that person essentially starts writing some parts of the prescription, right? So let's say they start writing symptoms, automatically the tool suggests diagnosis. Once the doctor chooses one of those diagnoses based on what the profile of the user is, the system automatically suggests medicines and their dosages, right? So this makes prescription writing and all of these things very, very easy. Similarly, if a fitness coach is trying to create a fitness plan for you, as soon as the fitness coach enters some data about, let's say, users preferences, oh, this guy wants to work out in a gym, this guy wants to run on his own, this guy really likes swimming, this guy has a wrist injury, automatically the system starts suggesting the plan, right? And what the expert just needs to do is just choose some things and edit some things. So even if the whole plan or the whole prescription is even multiple pages long, it just takes less than a minute to actually enter that data, right? So that is one benefit that you get out of it, which is super high productivity from these experts, so that they are able to do their job really, really well, rather than just this data entry kind of a thing which takes most of the time, right? That is one benefit. And second is obviously towards the customer, because most of the time from the expert is now going into actual intelligence. The plan that comes out of it is super super high quality and super personalized, right? So people none of our as you said, patients, but none of our customers actually ever say that this was bad quality or this thing was not considered even though I mentioned it, but this thing I mentioned three consultations ago, why was this not considered? Because everything finally flows into one data store, and everything is integrated. So both on the our expert side and our customer side, we are able to do the job really well, because all the data is in one place, and systems talk to each other.
Thanks, Ankit. And how are you able to, you've got presence in the doctors, you've got a pharmacy distribution, fine, and you also seen compliance to prescription is less. How are you using tech to just improve compliance to medication and engaging the patient, because that's a very important part of the treatment pathway too.
Right. So the way we are kind of leveraging data across all of these segments that we operate in, right? It's essentially to start first with little things. The doctors, for instance, especially the ones who've been doing practices for decades, they generally have a very strong point of view on how the software should work with them, right? So the amount of learning that you can do, if you look at it, right? I mean, I'm just dumbing it down the use case of a typical doctor who's not looking at a complicated case, right? For most cases, it's a set of it's kind of a hash set mapping, right? You have a bunch of symptoms and you map them to a bunch of treatments or therapies. You try the first one that fits the bill. If that doesn't work, then you try the next one, and that's how it kind of goes, right? I mean, this is very obviously a very simplistic way of putting it. There's a lot more involved, but doctors generally would not want systems to, trump their opinion, right? So they need to work with the doctor, not ahead of the doctor. And that's where the products that we are building today, they customize themselves for the need of the doctor. Similarly, when it comes to the patients, right, they are small nudges in terms of dietary plans, in terms of medications that they have to take, in terms of the refills that they need to have. So these are small nudges. I think once people get used to the whole idea of technology not being evil, because sometimes there is that perception, unfortunately, I think a lot more efficiency will come about, right? And that's what we are seeing now, especially after COVID. What has happened is that a lot of doctors were skeptical of using, video consultations, for instance, right? When COVID hit, we saw that almost 90% of the doctors had no practice. There was no practice. The clinics were open, but people were not coming because of lockdown, because of the general fear, etc. And suddenly there was adoption of video consultation. Of course, government also clarified things because it was in the gray area. Government came out with regulations and things were clarified by the government as well. People started using chat as a mechanism to interact with the patient. So I think things are changing right now. But right now the technology kind of operates in the shadows of the doctors or the patients, not in the forefront yet. Like how e-commerce is today, right? After 25 years of Amazon's effort, today now Amazon is able to recommend things to us as consumers, and we are very happy to consume it. I think we have just begun our journey there. And over the course of the next 4 or 5 years, I believe that there will be more openness to technology suggesting treatments, technology suggesting course of actions for patients and people who are looking to be healthy. So that's how currently we are kind of in the shadows, doing it slowly, steadily.
No, Abhinav, you're perfectly right. The only thing is, I don't think you are in the shadows. You are forerunners. Fine. So feel like a forerunner. 5 years later, the world is going to be very different.
Right.
Fine. That's the way the world is going to be. And I know Guru is waiting for talking about AI imaging. I'll let him do it, but I'll have a question for all of you guys at the end. Fine. And that's always been debated, but I think there are clear answers. And we'll do it after the end, so you can think about it. And but do that, who should the data belong to? Should it belong to the patient or the doctor? So I'll leave you with that question, and I'll let Guru have a few more discussions, and then we'll come back to this question. Hey, Guru. Over here.
Hey, thank you, Amitabh. Yeah, so this is to Dr. Geeta, and she can go first, followed by Bala. So, Dr. Geeta, you have talked about AI in medical imaging, and when we always, and obviously cancer and breast cancer, especially in India, is a very big topic. And when it comes to AI, everyone talks about accuracy of the model. How can I trust your model? And when it comes to cancer, it's all about how do you diagnose right and how do you diagnose early so that you are able to offer a much better preventive curative mode of treatment before it gets too late. So can you elaborate a little bit more about what problems have you solved in terms of being able to catch this symptom early through your AI technique?
Sure. Glad to be panel. So it's great to hear different AI use cases in healthcare from across the roundtable. What we have attempted to do is probably a very bold step, saying that, can we sort of go and solve a problem that is not being solved, even with expert doctors, not just in India, around the world, right? So that problem is about detecting early stage breast cancer in women of all age groups. And the next thing is like, even in other category of women, let's say above 45 years, where mammography is very, prominently used, it's being done using radiation, essentially X-rays, right? So that is also, we all know it's not the best way to catch cancer because obviously radiation exposure, however small it is, it's not great to your cancer risk. So what we're trying to do is something that almost like has not been solved before. And we are trying to do this completely because of machine learning and sort of that as the main tool for solving it. So just to sort of, that's the sort of the high level, high part of it. But in actuality, what we have done is to look at a completely different modality, which was initially used and thrown away because, it was very hard to interpret. This is thermal imaging, and put an AI and give a sort of a renewed life to it and come up with this technology. We call it as thermalytics, a combination of thermal imaging and AI, which enables detection of the smallest of the cancers, 4 millimeters of cancer, which is very, very hard, definitely to find by hand. What you can find by hand, which is what most of the people in India find breast cancer with, is about 25 millimeters, and we are able to catch them 4 millimeters. It's really, really less than 5 times the size, and so as earlier, very, very early on. And of course, you can always correlate it with breast MRI and so on, but clearly, you're not doing breast MRI for all of the ladies in the world, right? So that's not a screening method. So that is one big change we have done. How can we detect early signs of cancer very, very accurately as current tests, in fact, better than the current tests that are available, and doing it in a way that it is completely radiation free. So you can actually do this test as often as needed, because otherwise mammography can only solve once in 2 years. So you person can get cancer in between the two tests, right? So catching those sort of frequent times goal that we have gone after, and it's really good. Machine learning works, and when we started off this, the first working algorithm like 3 years ago, it was giving good results, and all. That's the reason why sort of we all decided to go for this startup, but that was in a lab setting. And so we've learned a lot over the last 3 years in terms of how to make this solution really work. In rural areas, we can actually make a health worker do the complete screening in 15 minutes and then do a provisional reporting and triaging solution, so that we can bring the who is likely to be malignant to the hospital for a further follow-up and diagnosis. So that's the sort of the screening use case that we are going after, where the tool takes over the complete end-to-end, early diagnosis of this of the disease. And the disease, as you can imagine, is also life and death kind of a decision that's making. So that way, I think, we've I'm so glad as a technologist to see that machine learning is able to do this, right? We are able to sort of train the models to fit to that such a critical sort of a use case, so that sort of gives me a lot of hope for what we have, like Amitabh was mentioning, in future coming, right? It's not about replacing doctor. It's really about providing healthcare to everyone in an affordable and an accessible manner. And so sort of some of the things that we have learned, just to sort of bring some additional insights, is like when we actually give these tools to the end users who are just health workers, maybe 12th class pass, who know how to, click a button in the software and so on, we find that they make a lot of errors in imaging itself, right? So we ended up, coming up with a lot of patents also in trying to figure out how do you know that the health worker is following the right protocol. How is the imaging good enough for the analysis? Because garbage in is garbage, and all of us know this. And so we want to make sure that we don't make that mess, right, in a very critical scenario of this nature. So we ended up innovating a lot of machine learning enabled techniques to even figure out the quality of imaging. There are so many such things, right? The overall solution now has about 15 plus machine learning algorithms in trying to sort of automate that full cycle. And the good news is that this is just one thing that we want to attack well and solve it and see what is the sort of the go-to-market strategy, what are the regulatory pathway hurdles, everything. And then this is repeatable for other type of cancers and other type of diseases. And that's what excites me a lot in terms of future of healthcare, where we can have machine learning. I can go on and on. I know we are at the end of the session.
Thank you, Dr. Geeta. Just one follow-up question, if you don't mind. So can you tell us a little bit about how, what kind of tool is this? How do people use this? How easy or how difficult it is to use this tool? What kind of training is required? How do you collect that data? If you can just spend another 2 minutes about this life cycle of, how does a patient gets tested using this tool, and, how does she gets the result? That would be really helpful.
Sure, happy to. So, we host our production server on AWS. So, and then it's basically a SaaS model where it's essentially a web-based tool, thermalytics.com. Basically, there is a thermal imaging device, which is basically a thermal camera, which is used in COVID screening. Same thing, a specific resolution. So we make the person sit in front of thermal imaging device for about 10 minutes with a cooler, and 2 minutes of imaging. She just sits like this and turns on the stool, and we take the full 180 degrees view of the breast region, thermal signature, not a normal image at all. And then these 5 images are uploaded into the cloud service. And then, and of course, a little bit of the patient information about some of the risk factors and age and all that are taken in. And then we use deep learning for several of the processes at the back end, as well as the final analysis is, is semantically enabled machine learning. Right now we use random forest, but essentially there are certain features extracted through sort of deep learned networks and certain features which are semantic in nature. And then all these get into a sort of ensemble learner, and then output is a complete 3-page report, which is sort of understandable by a doctor. So that's also very important, because it's not just enough to say, yes, she's cancer or she's likely to be cancer or not. We give obviously the probability of malignancy. In addition, why does the machine think that she has this probability? So we have like sort of different kind of analysis, like is it because of high blood vessel activity that we are seeing, or where is the cancer? Can you mark it? All this marking is also done automatically using image processing coupled with sort of pixel level analysis. And then, so essentially the end process is completely no touch, no see. The person sits and goes into a booth. She comes out after 15 minutes, her 3-page PDF report will be ready. So that's sort of the simplistic use case. It's completely privacy aware because nobody ever sees the person or touches the person. From a tech perspective, there's a lot of machine learning happening once the images are uploaded to generate the PDF report. Happy to talk more, but I'm conscious most of the time.
Thank you. This was really, really helpful. So, Bala, do you want to talk about what HEDUFO does in terms of AI and spectral imaging devices, and how are you, helping with predictive analytics?
Sure. So let me first talk about the problem that we are addressing. So we work in skin and soft tissue infections. So basically looking at wound care for a start and later into cosmetics. So in wound care segment, there are a couple of areas that we are focusing on. So first application we started is in, hello, are you able to hear fine?
Yeah, please go ahead, yes.
Yeah, so the first application that we started was, it was a very interesting incident. We had a chance to visit D.Y. Patel Hospital, and we had a patient sitting there who has been going to various hospitals for 3 months. And the doctor had been giving so many antibiotics, but the disease has not cured. So when we talked to the doctor and the patient, it turned out that the guy had a fungal infection, and the doctors kept giving him antibiotics for close to a year. Right? So we said that there must be a better way to understand what is causing the infection. So though you have a culture test where people are supposed to take a swab and tell what bacteria is infecting the wound, but most of the labs in India don't have access to these high-end facilities. So what happens is, let's say a diabetic foot patient comes, and then he takes, and the doctor takes a look at it. So he doesn't know what bacteria is infecting the wound. So he prescribes generic antibiotics. So this is a problem that we wanted to solve, that how do we reduce the decision time from, let's say, 1 or 2 days, which is taken for a culture test, to an instant decision, because doctors we know are not as patient as engineers. So we have built a multispectral device integrated with autofluorescence. You would have seen a lot of devices using multispectral imaging, but this is a completely label-free. The doctor doesn't have to do anything. So we take close to 15 spectral images using the device within a matter of 30 seconds. So we compare that from 2 days to 30 seconds. We get a decision close to 90% accuracy on what is the bacteria or the fungus that is infecting the wound. So the AI comes into picture because obviously a doctor doesn't have expertise in analyzing multispectral images. And there are so many features that we have learned which are non-linear features when we looked at the spectral images, because there is a whole suite of gram-positive and gram-negative bacteria where you cannot look at a wound in normal white light image and you can tell. So this is the AI part that we had looked at, how to transform the decision-making process of the doctor so that he can instantly prescribe right antibiotics to the patient. So the second part is obviously when we're talking about integrating AI, most of these hospitals may not have access to good Wi-Fi. And if I have to send 10 MB images, that takes a lot of bandwidth. So we have done a resource-constrained AI optimization so that the inferencing is done on the device itself and the doctor gets instant decision. Simultaneously, we are uploading the images to the cloud so that we can learn from the data that is generated. So this is regarding the wound care segment. Of course, the platform is quite generic. We are looking at hospital-acquired surgical site infections. We are looking at burns. That is mostly in terms of the medical space. Going forward, we are talking to a couple of MNCs such as L'Oreal to incorporate similar hardware platforms into skin care. Whether it's combined with acne or we're talking about dandruff, all these applications.
Thank you, Bala. That was really helpful. So this was really, really helpful. Thank you. Amitabh, do you want to go ahead and ask your final question and wrap up?
Yeah, thanks a lot, Guru. So, you guys, as you see that this is a phenomenal panel. Some people are creating the data by imaging. Some people are managing the data by digitization of the clinic. Some people are even managing exchange of the data. And fundamentally, once we do that, we'll actually have a healthcare platform which actually is better than the West at the cost that you guys are looking at it. So you guys are health tech pioneers. I have one last question, fine, and we can just go yes and no, and we can go that in the order that I see. Bala, who should own the health data? Is it the patient or is it the doctor or is it the third person? Fine, just 1, 2, 3. No debate.
Patient.
Good. Geeta. Geeta?
Yeah, patient.
Abhinav?
Patient for sure.
Ajit?
No, patient.
I see a smile, everybody. Fine. And Amit? I think Amit is mute.
I'm sorry, it's patient.
Patient. Ranga?
I really feel like being the source here and calling it the doctor. No, so patient. Yeah, it's hard to get the answer, honestly. Yeah.
Yeah, it's patient, definitely.
Richard? Arya?
Yeah, it's patient.
Now, I think I completely agree with you. And I think with that, thanks guys for attending this. I love having you here. Privileged to talk to all of you. Thanks for taking the infrastructure in India. We love to work with you guys. Just treat us as your partners. Thanks a lot.